HPK jumps 1001 to 1100. Let's begin. Murakami, say something.
I
Okay. A very long, thin, non-conducting cylinder of length L is centered on the y-axis, as shown above. Blah 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 blah. L greater than C.
guys, don't be like this guy. Actually read the question during the test.
On the figure shown below, draw an arrow to indicate the direction of the electric field at point P due to the long cylinder. Okay. Because it's plus lambda, this is going to have plus Q. And that makes electric field like this. So the electric field at point P is going to be up. And it's all symmetrical because like the x components cancel. Because it's symmetrical. Describe the shape and location of a Gaussian surface that can be used to determine the electric field at point P due to the long cylinder. So for a Gaussian surface, we want the electric field to be parallel to the area vector of that surface at all points. Does that look 3D? Surely, right?
Okay.
Yeah, right? Okay.
Yeah.
So we want a cylinder like this that encloses point P. Really
Perfect.
ugly. Perfect, right? And then that's our Gaussian cylinder with middle with wire in middle.
Coaxial, bro.
Coaxial. Okay, whatever.
That's the word you gotta use, bro.
No, I
Okay,
don't have
sure,
to
that
use
works.
coaxial. Yep, yap, yep, yap. Okay, let's use Gauss's law to determine the field at point P. So Gauss's law is the surface
Everyone should
integral.
know this.
Yeah, E dot dA equals
Like even I still
Q
remember this after a whole
enclosed.
year.
Yeah, over epsilon naught. Because we're doing cylindrical symmetry, that area is just gonna be, and like the dot product goes away because we're parallel, right? So it's just E times 2 pi times the radius, which is C, 2 pi C times the length of this, little l, equals the Q enclosed. So Q total is just the surface charge density, the linear surface charge density, times the total length, which means the Q enclosed by our cylinder is just lambda L times the proportion of the total length inside the Gaussian surface. So we get field equals lambda over 2 pi c epsilon. A proton is released from rest at point P. On the axis below, sketch the velocity v as a function of position y. Okay, so we know that the force equals the charge times the electric field. And we know that the field goes as 1 over the c, which is the radius. So it's going to start here at point C and then degrade like 1 over r. Okay? And we know for velocity that it starts at here at point C with 0 velocity because it says at rest. And we know that integral of acceleration is position. It's going to look like ln, like that.
Good job.
Yeah, great job. Okay, this is the D10.
This is not the D10. This is the easy part.
Oh wait, this is the thing where it gives you 2 points for just drawing a
This is
diagonal
like the
line.
D5, bro. This is like the slime IB in your level.
Yeah. Okay, because this part of the line is gone, some of this x component of field isn't cancelled by like this stuff over here. So like the net field is going to be that way. Is there a single Gaussian surface that can be used? No, because now without this part over here, we can't really encase that in anything. So, the field not parallel to area vector at all points, which is a necessary condition for using Gauss's law, like, in a helpful way. Okay. A student in class argues that using that might be a useful approach for determining the electric field.
Alright, it's
Okay,
D10
gives us
time.
2 components. If your teacher was good, they would like teach you like what the form would look like. So it looks like that pretty much. Like recognize the 3 halves and like pretty much all these cases there's a 3 halves.
Yeah, my teacher didn't teach me that, by the way, so I had to derive that shit
Yeah.
myself during the test.
There's 3 halves here, there's 3 halves here, there's 3 halves everywhere because you have to like resubstitute in terms of like actual variables, which is stupid. Okay, so we know that look at here. The vertical component no have the 3 halves, so that one's wrong. Identify 2 mistakes. So 3 halves power. Gosh. I can't write. Okay. Correct the mistakes. I don't know. And like
Add 3 halves power.
yeah. Like the whatever the answer he said, it's like ensure units are correct. Unit check. Field is in volts per meter or newtons per coulomb, whatever that is in like actual like base SI units. Who cares?
3 halves per 1 N.
Real. And there's also a dy here, which is silly. So we're integrating this way. Yeah, right. We're gonna integrate along this to find each of the dE's on this point contributed by this little dx times the lambda, which is dq. Right.
Yeah, so even though it says the vertical component, you're still integrating along the x direction of the
Yeah,
wire or
because
wherever
there's a
that is.
theta here somewhere, either theta there or theta there, and then you like
Oh yeah.
sine it or cosine it. Right.
Now you correct it. You change the dy to dx. This guy did not correct it. He gets minus point.
dy dx. Boom.
Yeah,
Okay, circuit
there we go.
question. Circuit question. Using Kirchhoff's rules, write but not solve equations that can be used to solve for the current in each resistor. Okay, pretty easy. Let's start with this loop. Voltage minus the voltage here from this resistor minus the voltage here from that resistor. Nothing, because we start and end at the same spot, so the voltage difference like should be 0. Let's do this loop next, actually this way, because there's a positive terminal. 6 minus 100 I3, 200 I2 equals 0. And then we can't use the third loop because that's just like a rearranged version of the first one, or the first two. So we're going to use a junction rule, like this. We know that I1 plus I2 equals I3. Okay. Calculate the current in the 200 ohm resistor. Okay, we actually need that I2, so we're going to solve for it. The I2, or let's get rid of I3. Probably, right? Should we do that? Oh wait, I'm bad at Kirchhoff. This is
I was like, what? Yeah, I was like, why is that I1 equals I2? I was so confused.
okay, there we go. Right, let's solve for
I was
I3 to get rid of it.
staring there. I was like,
My bad.
be
I3
that.
equals I2 minus I1. So let's plug it in here. We get 6 minus 100 I2 plus 100 I1 as distributive property minus 200 I2 equals 0. So we get, what do we get? Wait, this doesn't look right. Is it right? Probably.
Um,
What? Why are you umming?
uh, I think that's fine actually.
Oh, you're umming because it's like weird.
It looks weird, but I think it's fine. Solve the system of linear equations, okay? Better be able to do this shit.
Wait, this is like so weird. I had it like better before. I had it better. I don't know what I was doing.
Just keep solving it.
I
It's
don't
probably
wanna.
there.
I don't wanna.
You don't wanna.
No, like genuinely, what happened? Like
I
I
don't know,
had it like
bro. Your ass is ruined it.
I really have. Okay, you know what? We're just gonna that actually shows that I1 equals half I2 probably, I think, because I remember something. Let's plug it back in here. 6 minus 75 I2 minus 200 I2 equals 0. See, I solved for that somehow before, but like I'm too blind or something or too tired right now.
Okay, okay.
So we know that I2 equals 6 over 275 equals 0.022 amps. Okay. Power dissipated by
GG.
that. Power equals IV equals I squared R. Let's just plug those numbers in. Squared 200. Wait a minute. Did I get that before? Equals
My guy's
0.0.
failing arithmetics.
Did I get that before?
How the fuck did you get that? What the heck?
Uh,
You know what? That's actually probably right.
Is that right? I
I don't
swear.
know.
I swear that's fine.
Yeah, just trust it. It's probably fine.
Okay, whatever. Who cares? D10 anyway. The two 6-volt batteries are replaced with a battery of voltage epsilon and a resistor of resistance 50. Calculate the current through the 50 ohm resistor. Okay, first let's redraw this because I don't like it. 50
AP art.
AP art, yeah. I'm getting a 10.
Look at this guy's methodical drawings. I would never have done that.
Yeah, isn't this so great?
I would just have drawn over the freaking original graph and make it a mess.
You draw over it? That's crazy to me. And then this is 50. Boom. Okay. So we know that the voltage through here is 4.4 volts. And because these sets of resistors are across the same wire, that the voltage drop across these is also going to be 4.4. And then we can determine the current through a proportion, probably. Because this side with less resistance is going to suck in more current. Okay, so what did I do there? It was the 4.4 over... Oh, let's find the amps first, actually, in this one. Who's this?
No, 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 no,
No!
no. Shut up.
No, my
We're
video!
recording.
It's fine. 4.4 over 200 is the amp.
I see something that I hate very much.
We're in a recording. We're gonna teach people how to do HPK1 drums, okay?
Yeah, this is one
What?
drum.
Just
No,
Amps, okay.
wait. You actually is recording. I'm sorry about that.
So we know it's fine. I don't care. This is like a silly video. We know that IR equals IR. Because the voltages are same across this wire. So we do 0.022 times 200 equals the current through the 50 times 150. So we get
This brings so many memories back. I hate the E&M. Holy shit.
I50 equals 0.9 amps.
Yay.
Yay, okay. The 200
You
ohm
just skip.
resistor
You just
is...
skip a question.
What did I?
I don't think you did
Oh,
actually.
hey,
Oh, you
okay.
did. I was like.
Epsilon equals
Eps.
I total R equivalent. We know that I total equals these two plus 0, which is 0.051. Resistance equivalent, we're going to solve for that, I guess. So it's going to be 150 plus these two in parallel, which is making a lot of shortcuts here, but it's whatever.
Imagine you forget to bring your calculator in your AP exam. That'd be
Oh,
pretty
that
funny.
would
No, there's
that would
Desmos now, it's fine.
Oh.
There's just Desmos like on the
But yeah, you guys have it
like built in.
online
It's really
now. I
funny.
had it on
What
paper.
the fuck, bro? How?
Okay, anyhow.
235.7,
Solve this shit. Easy
you
question.
get
3
12.1
points.
volts. 3
Awesome sauce.
points, 3 points. D8, D10,
No, it's like
something.
5.
Okay. It's replaced with the capacitor now, and it's its steady state.
It's your favorite RC circuit
So,
time.
at steady state, this is full of the charges already, so it's going to draw no current. So it's just going to be this loop that's running, which is I equals VR equals 12 for the total resistance. They're just in series, so it's these three over 300. $40 amps. Okay, then the resistor is replaced with an inductor. Is the current in the 50 ohm greater, less, or equal to that? Whatever it was before. Okay, it's also at steady state, and inductors at steady state are just like wires because dIdt is nothing. So like the voltage through them is just like nothing. Which means the 50 ohm gets all the current now. Inductor acts as at steady state.
When do you have your AP physics?
Next week, Thursday. Which is gonna be fun.
Good luck.
Thank you.
Holy
Last
shit, I hate
question.
these.
Solenoid test.
Question.
Solenoid is
Solenoid.
used to generate a magnetic field.
Free question, guys.
Blah blah.
Every time
Free
you see a
question.
solenoid, it's a free question.
True, true, true. Okay. Select the correct direction of the magnetic field at point P. So in an ideal
The
solenoid.
only thing I remember is right hand rule, left hand rule. And also the
True.
fucking grip rule. Whatever the hell that is.
So by the right hand rule, you like my drawing? Remember my drawing from like 20 minutes ago?
This is the best
Okay.
right hand rule illustration of all time.
So when the current goes like this.
Unregistered.
Stop! Stop!
He's trying
Oh,
his
that's
best.
horrible. Okay. When the current curls that way, the field is your thumb. So it's in the plus x direction.
Yippee.
Yippee. Draw an Amperian loop that can be used.
3 point again.
3 points. Just make sure it doesn't go outside because there's edge effects. Make sure it's inside the solenoid. Use Ampere's law to derive an expression for the field strength. Okay, Ampere's law is this. B dot dl
Pregnant integral.
equals mu naught I enclosed. Okay. So we don't have to worry about the dot product or whatever. So it's just B times. There's only field in here, so that's gonna be the only like leg that gets any field. So it's just B times little l equals naught, and then the I enclosed is the total current times the number of loops times the proportion of that like loopy current inside our Amperian loop, which is little l over big. So the field at point P, mu naught I n. Okay, we have an experiment to determine the solenoid's resistance. Blah 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 blah. Okay. Strength B as a function of EMF. On the graph
It
above,
literally
draw
gives you the points, bro. Just draw a line of best fit.
right. It's kind of like that. Okay.
Good enough.
Yeah. And because we know this, then we know that I R n over LR times epsilon, which is just y equals x, right? So the slope is this, and we have our two relations. Okay, so let's find the slope. Let's like use some good points. Do which points look good, chat?
Y equals to 2.
I
That
mean
looks
the
really good.
Like, oh right, okay, that one's fine. And I guess we use that one.
yeah.
Okay, the slope equals 2. That's the 2, and that's like, this is times 10 to the minus 4 because of the units. So this should equal something, probably. Equals 0.6 times 10 to the minus 5. Okay. Now we solve for R. R equals 4 pi times 10 to the minus 7 times the number of loops 100 times the length, which is plug that in a calculator.
Get something.
Equals 8.7 ohms. RS. Okay. Is there evidence from the graph that the horizontal orientation? Yes. Because there's a y-intercept. Would the horizontal orientation affect the value of RS? Well, we know that by our graph, the resistance is dependent on the slope only, and that horizontal direction, like, of field will like add to every point, so it doesn't really affect the slope. Okay. A thin conducting.
Last question.
Last question. Last question. What
Yippee!
jump is this?
Jump 1098.
That's like hard.
What
Okay,
if
yeah,
it is D1?
That's
this
D10
question is actually not
plus.
that. Question is actually not that hard. I say this is the X facing piston base to piston base knee up.
Ew. Ew, is it hard or is it just Chinese turn and get lucky?
It's both hard and bad,
Oh my god. Is the
which
direction
is
of the induced current that way or that way? Okay. So it's the current is decreasing. So it's going from like really strong this way. I'll make it like a better color so you can, it's going from really strong this way to like weaker and weaker and weaker. Right? So the loop doesn't like that. So it wants to like counter by making its own this way field. And by right hand rule, that should be clockwise. Right? Right guys, right hand rule. That way.
Nice drawing.
Okay. That's like Lenz's law probably.
Yeah, it is.
Okay. Derive an equation for the average induced current in the loop. Okay. So we know that EMF induced equals minus flux. So like we're using averages here, so it's like whatever. Flux over like delta T. Right. The air, we know that flux equals the field times the area, and the area is staying constant. And we know that the field is, or first we know that the area is just this area, because there's only field inside the solenoid. So that's going to be pi times a squared. And then we know the field is whatever we had up here, mu naught I n over L. And then times delta time. And then we also know that which is this, boom, done. All D10s.
Yippee!
Yay!
congratulations.
Yay! Yay! That's
Oh, the
perfect.
R is RL, by the way, it's not RIS.
Oh, right. R of the loop. Because the resistance of the solenoid, who cares about it?
Yeah.
Yay! Done. All
Congratulations.
D10s done. All jumps
Yeah.
done ever.
All jumps all the jumps 1001 to 1100 complete.
Yeah! Stop recording.